Alright, so this video is going to be covering the McGurk effect, and we're going to get to the effect in just a moment. What I want to do is tell you a little bit about what we're going to cover in this video. First, I'm going to show you an example of the McGurk effect, so I'm going to show you the effect in action, and then we're going to go and look at the first study that looked at all of this. So we're going to be looking at the McGurk and Macdonald 1976 paper. So we'll break through those methods, those results, and then we'll talk about why the McGurk effect happens. So what is it about the human brain that allows the McGurk effect to even take place? And then we will cover a more recent article that dives into this question by Beauchamp, Nath, and Pasalar, and this is in 2010. Okay, so let me show you an example of what the McGurk effect looks like.
Ba 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 ba. Ba 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 ba.
So that's the basic effect. This was initially studied in 1976, and it was done by Drs. McGurk and Macdonald. And what they were interested in is how things like nonverbal cues are able to inform how we understand language. And so what they did is they had some preschool kids, some children, and some adults, and then tested them on varying auditory stimuli and visual stimuli. So just like in the clip that you saw just before, there were some times where you would hear ba with a B, and sometimes you would see ba with an A being formed by the mouth. But then there were other times where those syllables were mixed up. So sometimes you would hear BA, but you would actually see someone making the mouth of something like GA. And what happens is that whenever those are paired together, the brain basically says, "Hey, this isn't right. This isn't compatible. I've seen that that the lips are forming a GA sound, and the point of articulation of the lips doesn't match a BA sound. And so the most likely outcome is a DA or a DA sound." That's the math that our brains do. If you play that clip with the sound turned off, you will experience something else. If you play that clip with your eyes closed, you will perceive something else. And as far as we know, the McGurk effect is the only effect in psychology where you can take two stimuli like that, add them together, and get a third percept that is entirely different than the first two. So it's not a combinatory effect, it's almost like a transformative effect. So you don't hear a combination of ba and ga. Instead, you get a completely new percept that's informed by kind of like a mismatch of what we see and what we hear. So it's not a surprise that this article is called Hearing Lips, right? Because what's happening is that it's showing that visual cues can actually change what we perceive to hear for language. And they're using very basic, stimuli here. We're just talking about little syllables or phonemes. But these have some pretty big implications because it shows that how we perceive speech isn't just auditory. It's not just, communication through hearing. It relies a lot on what we see, which makes this a top-down process. And a top-down process basically means that your expectations about the situation are going to inform what you perceive. So, as I mentioned, McGurk Macdonald, what they did in the 70s is they basically showed what I just showed you, and they tested this with preschool kids, with slightly older school children, and with adults. And what they found was actually really interesting, because not only was this the first study to show that this effect exists, They also found that this exists primarily in adults. We don't really get this effect so much with children. In fact, if we're looking at, if I asked you, what's actually being said here, children and preschool kids are actually much more accurate than adults are. Adults like to get it wrong. We like to, as adults, marry these two stimuli, the visual and the verbal, or the auditory. We like to put those together. We fuse those. Our brain takes care of that and we don't think about it. Kids, on the other hand, they don't. They rely more on either vision or hearing. They don't quite put them together the same way. So what they have is more of a bottom-up process where they work with just the raw sensory information, just hearing a ba or just seeing a da, or a ga on the lips. They don't put it together like we do. Why is that? Well, because adults have much more experience looking at faces and hearing people communicate. And so we use our vast kind of experience doing those things to learn that whenever you see a mouth that's saying ga, that there's no way that the sound that could be coming out of that person's mouth starts with a B, because a B, the point of articulation is the lips. So you would see a B sound that the speaker was making. Okay, so that's the McGurk Macdonald effect in a really tight kind of summary. If you haven't read the paper, it's only 2 or 3 pages long, and most of that's tables. So you should definitely check it out because it's really interesting. But since then, people have been wrestling with, well, why does that happen? And it seems like it is kind of this top-down attentional process that we have. But more recent developments using neuroimaging have actually shown us a little bit of a more interesting story to this. And what they show is that there's an area of the brain that's going to marry visual information and auditory information. This area is called the superior temporal sulcus. So I'm going to talk about this Beauchamp et al. Article from 2010, and what they're going to be using basically 2 neuroimaging methods. They're going to be using MRI, or magnetic resonance imaging, and they're also going to be using TMS, or transcranial magnetic stimulation. Okay, so the first, and so I like to think of this, as a 2-part experiment. That first, what they do, before they even get to what they're trying to test, what they do first is they bring people in to an fMRI machine. They have them experience stimuli. So they're going to have them look at someone speaking. They're going to have them hear someone saying words, and they're also going to have a condition where they look at both of these things. So they're looking at a speaker and also hearing what they say at the same time. So that gives us 3 conditions. And so what they're doing with that is that they're looking at brain activation for when someone's talking, so just auditory. They're looking at brain activation whenever someone is speaking, so just visual information about the face. And then they're also looking at information or the brain activation whenever someone is doing both. So whenever we are perceiving someone talking by visual and auditory means. What they were interested in is basically subtracting all of the activation from the for the auditory brain activation from whenever they're combined, and also for visual. And what it's going to do is basically, by taking these other 2 auditory and visual conditions, subtracting that out of the condition where they have both, is going to isolate the area that should be responsible for combining those experiences of auditory and visual. So they did that. So this kind of 3rd condition where they had both auditory and visual stimuli, what they did is they took that, and what they were left with was basically the superior temporal sulcus, because the visual cortex, that wasn't really left, because that was subtracted out. The auditory cortices, they weren't there because they were also subtracted out in the first condition, which just left the superior temporal sulcus. That's the first part of this experiment. The second part of this experiment involves TMS, and if you're not familiar with TMS, it is really very pointed, powerful localized magnet or magnetic pulse that temporarily scrambles brain activation. It's not permanent, it's very temporary. It's done a lot for temporary lesions, which is a fancy way of saying that, kind of knocking out brain activation for a very temporary amount of time, a matter of seconds. So if you haven't seen those things before, check them out on YouTube. They're really interesting. But what Beauchamp and colleagues did in this experiment to test the McGurk effect is they basically got people to watch the McGurk effect videos. So the same videos that I was showing you, where you have someone say, you hear ba, but you see ga, and normally we would perceive da. So da, da, an entirely new percept. What they did with the TMS device was, while that video was playing, they would zap that part of the brain, the superior temporal sulcus, whenever that stimulus was being presented. And so their hypotheses were that basically, if this is the area that combines auditory and visual information, that if we temporarily knock it out, that we shouldn't see this McGurk effect. That people should either say ba or they should hear ga, but they shouldn't perceive da, because that relies on us combining those two stimuli. And that's exactly what happens. In their results, you can kind of see even a time course of when they administer, this temporarily knocking out the superior temporal sulcus, that by doing that, it drastically decreases the rates of perceiving the McGurk effect. So, what does this all mean? It means that the McGurk effect, I like to think of it as taking place on two different levels. One, we have a top-down process, which means that our expectation is driving our perception of this. So by seeing someone say something and hearing something, it gives us this new perception of something we didn't actually hear or see. The second part of it is that the reason why this is happening at a neurological level is because of the superior temporal sulcus, which is just an area of the brain that helps combine auditory and visual information. So it's used for multimodal integration. All right, so that's pretty much the McGurk effect.